What's up guys, welcome back to the channel. Today on this video we'll be doing the question paper that you see on the screen. This is a national certificate for mathematics N4, and this paper was written on the 24th November 2025. It was an X paper that took 3 hours to be written. Before we start with this question paper, we'll be focusing on question 5 on this particular video. But just in case you want to watch videos on question 1, 2, 3, and 4, you can always go to the description. I left the playlist that contains those questions. You can click on that playlist and watch the videos, or the icon will pop up on the top right of the video that you're watching at the current moment. Before we start again, I'd like to say thank you very much guys for watching, subscribing to the channel, commenting, not forgetting those who share the videos. If you haven't subscribed to the channel guys, subscribe to the channel. Before we solve question 5, I'm also going to leave a timestamp for each and every question that is in question 5 so that you can able to watch a question if you don't like to watch in a sequence order. Alright people, we are done with the introduction. Let's go and look at question 5. Alright guys, here's our question 5. Now question 5, it is based on integration. So as you can see here, it has about 4 questions with sub questions in there. So we're going to start with 5.1, which is this one here, and then we're going to create a space and solve it. So let's go to 5.1 and let's solve it. Alright, here is our question 5.1. Now let's read the question and let's solve this problem here. Integrate the following with respect to x. Now this is a polynomial. They want us to integrate each and every term of this polynomial. So if I count here, we have 1, 2, 3, 4, 5, 6, 7 terms. So we need to integrate all these terms. So before we do that though, we need to simplify some of the terms before we integrate. So I'm going to rewrite this question and simplify the terms that need to be simplified. So when you are simplifying, you also need to keep the sigma there, open bracket. So the first term we have 4 multiplied by 5 to the power of 3x. So 5 to the power of 3x, it is simplified. We can integrate this. Let's do the second term. So the second term, there's no simplification required there. We have 4 cos 4x. No simplification required there. And then we go to the third term. We have 7 sec squared. Also, there's no simplification required there. 7 sec squared x. Let's go to the fourth term. Now we have minus. We can say pi over 2x multiplied by 1 over x. Right, decided to separate them. This is the same as pi over 2x there, but decided to separate 1 over x with pi over 2. Then we add them. The fifth term, we have sine 6x. No simplification required. The sixth term, we have negative 2 over 3, but we have root of x cubed. So we can write this term like this, open bracket, x cubed. Instead of writing the root, we can write in terms of exponents. We have 1 over 2, the power there, and minus. The last term there, it's also fine, no simplification required. We can say 1 over 2 multiplied by cosec 2x multiplied by cot 2x, close bracket, dx. Right. Again, we still have to simplify this term here because of these exponents there. As for other terms, they are already simplified. So since we are simplifying that term there, we need to rewrite all other terms there. So let's continue. We have sigma, open bracket, 4 multiplied by 5 to the power of 3x plus 4 cos 4x plus 7 sec squared x minus pi over 2 multiplied by 1 over x plus sine 6x minus 2 over 3. Now let's look at x there. We have x to the power of 3 multiplied by 1 over 2. So we can say x to the power of 3 over 2. There we go. Minus 1 over 2 cosec 2x multiplied by cot 2x, close bracket, dx. Right, so when it's like this, now we can able to integrate each and every term that you see here. Now the next step here is to recognize the functions and know which integrals are they. Now let's start with the first term. we have 4 multiplied by 5 to the power of 3x. Since we have x as an exponent, this here is an exponential integral. So when you integrate this, we can say y is equal to, we have the coefficient, which is 4 multiplied by our base, which is 5, and exponent 3x there. But this time around, we have to divide by the coefficient of x, which is 3 there, and also that 3 we multiply with natural log base, which is 5 there. There we go. Again, guys, this is a exponential integral. Just in case you don't know much about exponential integral, you can go to our description and click on the video where I explain this type of integral, and the very same video will pop up on the top right of the video that you're watching at the current moment. Now let's go to the second term. Now the second term, we need to integrate 4 cos 4x. Now first we have to add the coefficient there, which is 4, and then we integrate cos. So the integral of cos, we know that it's going to be positive sine 4x, and then since we have the coefficient of x there, it's going to be divided by 4. Again, people, this term here is a trigonometric ratio, so meaning this is a trigonometric integral. Again, if you want to learn about trigonometric integrals, I left the video there. You can go to the description and watch the video based on trigonometric integration. Right, let's move to the third term. We have 7 sec squared x. Now this one here, guys, is very tricky if you don't understand, but we know that 7 is our coefficient. We need to integrate sec squared x. Now remember, integration is the opposite of differentiation. When you differentiate tan, you get sec squared x, meaning that the integral of sec squared x is actually tan x. Right, so let's write tan x. Right, so let's go to this term here, which is our fourth term. We have minus pi over 2 multiplied by 1 over x. So this one here is actually the integral of log. Some of you may wonder, how do you see it? We have 1 over x here. This here, guys, is integral of natural log. As for pi over 2, these here are just coefficients. So we're going to continue, right? Negative pi over 2 multiplied by ln x. There we go. I hope you guys know this. It's really simple. Again, if you don't understand it, you can go to our description, go and watch a video based on this type of integration, which is a log integral. Again, the very same video will pop up on the top right of the one that you're watching at the current moment. Now let's go to the fifth term, which is sine 6x. So before we solve this is a trigonometric integral, so we know that this is going to be plus, but then we need to integrate sine. The integral of sine, we know that it's going to be negative cos. Now instead of writing s, we're going to write 6x, and then we're going to divide by the coefficient of x, which is what here, which is 6. There we go. And then we do the sixth term here. All right, before we go to the sixth term, let me create a space because it really gonna need us to have space here. It's gonna be minus 2 over 3. Then we have x to the power of 3 over 2. Remember, this is the standard integral, so you must add plus 1 there. And the very same 3 over 2 plus 1, you have to divide by it. So we can divide by 3 over 2 plus 1. Here we go. Then before we do the last integral, this is a standard integral, guys. If you don't know how to do the standard integral, you can always, guys, go to the description. I will leave the video where I explain the standard integral, and the very same video will pop up on the top right of the video that you're watching. Go and watch there in order for you to understand this type of integral. Right, so let's do the last one. We have negative half cosec 2x multiplied by cot 2x. So we're going to write plus half and then cosec 2x over 2. Right, let's create more space there to finish everything, plus c. Some of you might be confused, why do we have to have plus there? Because this is a negative there. Well, it's very simple, guys. Remember, the derivative of cosec x is actually dy over dx is actually negative cosec x multiplied by cot x. So since this one here is negative, when you go back, this is gonna be positive. I hope you guys understand. Right, so we are done there. Let's not forget to add plus c. So guys, this is how you do integration of a polynomial, but we're not done because we need to simplify. So let's simplify it further. As for the first term, with y is equaling to 4 multiplied by 5 to the power of 3x divided by 3 ln 5. There we go. And then second term, we have this 4 divided by 4, and then we only left with sine 4x. There we go. Third term, nothing you can do there. Just write it as it is, 7 tan x. Fourth term, again, nothing you can do. We just have negative pi over 2 multiplied by ln x. And then the fifth term, we have negative cos 6x divided by 6. So it's going to be negative cos 6x divided by 6. And then the sixth term, we have to simplify it further. Right, so when we simplify this term here, we have negative 4 over 15x to the power of 5 over 2. And then the last one, on the numerator, we have 1 multiplied by cosec 2x. So it's going to be cosec 2x divided by, we have this 2 and 2 multiplying each other on the denominator. We have 4 there, and then plus c. Guys, this is how you do the integration of this polynomial. Just in case you didn't understand how to do this, you can go to the point where you got lost and rewatch them. If that doesn't help, you can always leave a comment in the comment section. I'll try to help you to my level best. Guys, we are done with 5.1. Again, I'm going to leave a playlist on polynomials on the description. Go and watch those videos where we solve problems similar to this. And also the very same playlist will pop up on the top right of the video that you're watching at the current moment. All right, people, we are done with 5.1. How about we do 5.2? Alright guys, here is our question 5.2. Now, as you can see here, 5.2, it has 5.2.1. Let's read the question and solve this problem. The question goes like this: sketch the curve of y is equaling to 2x to the power of 3 minus 2x, and show the area and the strip enclosed by the curve y is equaling to 2x to the power of 3 minus 2x, and the x-axis which lies in the second quadrant. Now, they want us to sketch this graph here of the function there, and also they want us to show the area and the strip enclosed by the curve that we are going to draw. So the curve and the x-axis, those are the things that are enclosing the area. Just in case you didn't know, this is actually the cubic graph. So let me rewrite the function there. We have y is equaling to 2x cubed minus 2x. Now I want us to draw this graph. So when you draw this graph, you can start by saying when x is 0, meaning when you substitute 0 where there is x, you must find y. So let's continue. Y is going to be equaling to 2, open bracket. Instead of writing x, we're going to write 0 to the power of 3 minus 2 multiplied by 0 because we have x there. So this means that y is going to be 0. When x is 0, our y is 0. So this point here, let's call it A. Let me highlight it so that you can able to see when you draw. This is going to be A. Now let's look at other coordinates when our y is 0. So we can say when y is equaling to 0, what is our x? So we're going to use the very same formula there, or the same function, in order for us to get our x values. Wherever there is y, we substitute with 0. So as you can see, if y is equaling to 2x cubed minus 2x, so instead of writing y, we're going to write 0 there, which is equaling to 2x cubed minus 2x. Now when it's like this, we start solving for x. So as you can see, on the left hand side is equaling to 0. On the right hand side, we have a common factor. Our common factor here is actually 2x. If you take out 2x here, you're going to be left with only x squared minus 1, close bracket. There we go. And then from here, we can say the following. You can say 2x is equaling to 0, and x squared minus 1 is equaling to 0 as well. So we can divide by 2 here, divide by 2 there. We know that x is going to be equaling to 0, so we are fine with that. As for this one here, you can say x squared, we transpose this negative 1 to the right hand side. This is going to become positive 1. So we're not done. So we can say x is still 0 this side, and this side here we want x, not x squared. So what to do, we square root both sides there. But when we square root both sides, our x become x, but our 1 become plus or minus 1, right? So we need to write our points there. Let me create a little bit of space so that we can able to write our coordinates there. So with this one, we have point P. For this one, when x is 0, y is also 0. Point C, when x is 1, or y is 0. The last point there, let's call it point D. When x is -1, y is going to be 0. There we go. Let me highlight them so that you can able to remember them whenever we are drawing our graph. So we are done with x-intercept of this graph. Remember, let me just remind you, a cubic graph is supposed to look like something like this, where we have 3x coordinates sometimes it's 2, sometimes it's 3. As much as this graph of ours, it cuts the x-intercept, it also has the turning points, guys. So let me show you the turning points. We have this turning point there and that turning point there. So meaning we need to find the coordinates of these turning points. So again, this one is also not that difficult. All right, let me erase this. We're gonna calculate our coordinates for turning point here on the side. We're gonna do it here. Remember, when you calculate for the coordinate of the turning point, you need to derive our equation there. So let's derive it. Dy over dx, right? This is gonna give us 6x squared minus 2. But let's not forget that you always equate it to 0. Remember that. Then from here, we have to transpose this -2 to the right hand side. So we're going to be left with 6x squared is equaling to 2. And from there, we divide by 6 throughout. As we divide by 6, on the left hand side, we're going to be left with x squared is equaling to 1 over 3. But we are not looking for x squared. We're actually looking for x, so we have to square root both sides. As you do that, we're going to be having x is equaling to plus or minus 0,577. There we go. Now, these are our x's. We need to find the y values. So we have to say when x is equaling to, remember we have plus or minus here. Let's say it's equaling to positive 0,577. What is our y? So we're going to substitute the x value here on the original equation then. So let's do it. Y is equaling to 2 open bracket 0,577 cubed minus 2 0,577. Then you have to put this on the calculator and then we find our y value. So when it's positive, we're going to find negative 0,73. There we go. So we can call this point here turning point 1. Let's create more space again. Let's call it TP1. So the coordinate here, we have 0,577 as x, and our y is going to be negative 0,73. So this is our turning point 1. Now we need to find turning point 2. We're going to do similar to what we did when we find turning point 1. So we can say when x is equaling to, this time around we put negative 0,577. What is our y? There we go. Again, we're going to use the formula, the original formula. This time around, we substitute with negative 0,577. So let's do it. 2 open bracket negative 0,577 cubed minus 2 negative 0,577. There we go. Put this on the calculator. Our y is going to give us positive 0,73. Right, let's write the coordinate of turning point 2. Let me create space. So TP2 is gonna be negative 0,577 for x, and as for y is gonna be 0,73. Right, let me highlight them very quickly. We have TP1 here, we have turning point 2 there. Now what is left for us is to draw our graph. Let me create a space again so that we can be able to draw our graph. All right, we're gonna draw our graph here on an empty space. So the ones that I highlighted in red, just know those are the coordinates of this cubic graph. Let me first create the Cartesian plane and then we'll draw our graph. All right guys, so here is our Cartesian plane. Now let's start drawing our graph. Now let's start with point A. Point A, as you can see, x is 0, y is 0. So this here is going to be our point A. right? Let's look at point B. Here's our point B. So point B and point A are the same. When x is 0, y is 0. So this is going to be point A, point B at the same time. Now let's look at point C. Point C, when x is 1, y is 0. So 1 is here and y is going to be 0 on the x-axis. Then let's look at point D. At point D, when x is -1, y is 0. So this here is going to be our point D, right? Because our x is -1 and our y is 0. Now it's time for us to draw the turning point. Let's start with turning point 1. Now turning point 1, when x is 0,57, which is very close to 0,6, our y is going to be -0,73. So let's start when x is 0,57. So 0,5 for x, it's somewhere there. Maybe somewhere here we can say 0,56. You take a ruler here, which is very close to 0,5, draw a line that is vertical, going upwards and downwards like this. There we go. Right. Now remember, our y is supposed to be -0,7. -0,7 supposed to be on the negative side of y-axis, very close to the middle between -0,5 and -1. So I will put it somewhere here. There we go. So this here is going to be our turning point. Let me just call it TP1. There we go. And let's look at TP2, this one here, turning point 2. When x is -0,57, y is going to be +0,7. -0,5 is somewhere here. Let me just do the line here. And then we draw a line, we extend it downwards like that. There we go. Now we need to find +0,73, which is in the middle between 0,5 and 1. So we can draw a line here again that is going this way. Take a ruler, guys. When this line meet, you draw the dot there. That's where they intersect. So we can call this one TP2. Then we start connecting. As we connect, you'll see that our graph will align. So let me start from here. There we go. Guys, here's our graph. It doesn't look that beautiful, but it is our cubic graph. So this is a graph that you were supposed to draw. For the marks that it has, it really doesn't make sense, but it's a graph that you're supposed to draw. Now, remember the question says you must indicate the area and the strip that is on the second quadrant. So as you can see, here is our second quadrant. Let me show you the area that is enclosed by the curve on the second quadrant. There we go. This is our area that they're talking about. It is enclosed by the curve and the x-axis. Now let's draw the strip. When you draw the strip, guys, just draw it inside the area that is highlighted. Just make sure you draw it inside there and highlight it. I hope you can see there, guys. So this is our strip there, and then change in x. There we go. And then you'll get your full marks. You have drawn the graph, you have indicated the area, and also you have shown the strip, so you will get full marks for doing this. We are done with 5.2.1. I hope you guys managed to understand this. It was really not that difficult. Yes, most people will get confused on this cubic graph, but they did mention that you only indicate the area on the second quadrant, which caused by the curve and the x-axis, and also show the strip. So this is how you do this one, guys. If you didn't understand, you can always watch at the point where you got lost, and if that doesn't help, you can leave a comment. I'll try to help you to my level best on the comment. But if this helped you to understand, people, do not forget to like, share, comment, and also subscribe if you haven't subscribed to the channel. Share this video to your friends who are doing the same subject. Guys, we are done with 5.2.1. Let's go and do 5.2.2. All right, guys, let's look at 5.2.2. Now, here's our question 5.2.2 there. They want us to calculate the area indicated in question 5.2.1 by means of integration. Look, guys, this is the area that we calculated earlier on 5.2.1. They want us to calculate the value of that area using integration. So let me create a space and do some calculation just next to our graph. So the graph is supposed to be seen as we do these calculations. All right, so let's start. Our equation for this graph is y is equaling to 2x cubed minus 2x. There we go. They want us to find the area by means of integration. So this one is very, very simple. We have to do the following. First of all, we need to use sigma. There we go. and then we need to find the upper limit and the lower limit. Guys, when you find the limit, it's not that difficult. You need to find the x-intercept of that area. If you look at our area that is shaded in green there, here's our x-intercept there, 0 and -1. So meaning those are our limits for this graph. When they ask you to calculate the area, only consider the x value of that area or of that indicated area. So let's go and write our upper limit. Our upper limit is the bigger number between 0 and -1. So 0 is going to be our upper limit. And then our lower limit is going to be -1, because between 0 and -1, the bigger number here, it's 0. Then inside there, we have to put in our equation that we have 2x cubed minus 2x multiplied by dx. So we need to use this here to calculate the limit. This is what we call definite integrals. Just in case you don't know much about definite integrals, guys, I made a video on definite integrals. You can go to the description and click on that video based on definite integrals, and also the very same video will pop up at the top right of the video that you're watching at the current moment. All right, people, let's continue with our calculations. Then say this is equaling to area, so we can say area is equaling to, open bracket, 2x to the power of 3 plus 1 divided by 3 plus 1. This is a standard integral, by the way, minus 2x to the power of 1 plus 1 divided by 1 plus 1, close bracket there, and then the upper limit and the lower limit. Guys, you don't need to add plus c because these are definite integral, right? So let's continue. Area is going to be equaling to, open bracket, so we have 2 multiplied by x to the power of 3 plus 1, that's going to give us 4 as exponent, divided by 3 plus 1, which is going to be 4 again, minus, we have 2, right? We have x to the power of 1 plus 1, that's going to give us 2 divided by 2, close bracket, and that is, we have upper limit and lower limit. Remember, these are not powers but limits. So we can continue here and say area is equaling to, now open bracket, now we're gonna simplify this. On the first term, we have x to the power of 4 divided by 2, because 2 divided by 4 it's half, minus, we have 2 divided by 2, then we have x squared, and then this one here we can say is for the upper limit. You're gonna always minus by the same integral with a lower limit, so we're gonna have x to the power of 4 divided by 2 minus x squared, open bracket, now minus 1. These here, guys, are not powers but limits. Remember these limits here from the beginning, these limits from the beginning, we are keeping them. We are indicating that we still have this limit. So the upper limit is going to be subtracted by the lower limit. So before we continue, let me create a little bit of space here. So let's continue. So wherever there is x on the first bracket, we're going to substitute with the upper limit, which is 0. So let's do it. It's going to be, open bracket, 0 to the power of 4 divided by 2 minus 0 squared, minus, open bracket, wherever there's x on this bracket here, we're going to substitute with -1. So open bracket, -1 to the power of 4 divided by 2 minus -1 squared, close bracket. Now we have to use our calculator. The first bracket, guys, we're going to have 0 if we use our calculator, and then we say minus. Inside this one here, we're going to have -1/2. So meaning our area, guys, is actually half. There we go, unit square. So I hope you guys managed to understand this. It required you guys to understand the indefinite integrals and limits as well. If you didn't understand the indefinite integrals and limits, then you're going to be struggling with this question. But basically, this is how we do this question. Again, guys, if you got stuck somewhere, you didn't understand, please rewatch at the point where you got stuck. But if you managed to understand, don't forget to like, share, and subscribe to the channel if you haven't subscribed. Guys, we are done with 5.2.2. Let's go and do 5.3. All right, guys, let's look at 5.3. Now 5.3, we are given this expression here. They say determine sigma, open bracket, e to the power of 2x minus e to to the power of 3x close bracket divided by e to the power of x multiplied by dx. Now this one here, guys, before we integrate, we need to simplify. So let me simplify it first. So as we are simplifying, you keep the sigma there. Let's do the simplification. I can write it like this: e to the power of 2x divided by ex minus e to the power of 3x divided by ex close bracket dx. Now using exponents, we can subtract the exponents there since all of these have the base of e. So we can write this like this: sigma open bracket with e to the power of 2x minus x. Because of this e, when it goes to the numerator, the exponent, they will subtract each other, minus, and we have this one here with e to the power of 3 minus x again close bracket dx. Now if you continue write this now can be as follow: we have e to the power of x, because 2x minus x is going to give us x, minus e to the power of 2x. Now we can say multiply by dx. When it's like this, we can start integrating. So let's integrate. Y is equaling to this one here. The first term, we have e to the power of x. This is the same as ex, no problem. And then the second one, we have e to the power of 2x. So we can write as negative e to the power of 2x, but we have to divide by the coefficient of x, which is 2, plus c. On this one, we need to include c because these are indefinite integrals. So if you continue, I'm going to continue here on top. The answer is going to be e to the power of x minus e to the power of 2x divided by 2 plus c. That's it. Some of you may wonder, why don't we have ln e? Ln e, guys, is equaling to 1. That's it. You don't have to worry about it. So this is our final answer, guys. This was straightforward, really not that difficult. All you needed to do is simplify. Again, just in case you didn't understand, you can leave a comment in the comment section. Also, you can rewatch the point where you didn't understand. If that doesn't help, leave a comment, guys. I'll try to explain you to my level best. Guys, we're done with 5.3. Let's go into the last question of this question paper, 5.3. All right, guys, here is our 5.4. Now 5.4, the one has to evaluate the following. Here we have the upper limit pi over 2 sigma, lower limit 0 open bracket with sine 2x multiplied by cosec x close bracket. They forgot to put dx there, but basically this is how the question is supposed to be. Now this question here, again, these are limits. I already left the video where I explained definite integration on the description. Go and click on that video. It will help you to understand what I'm doing here. So go to that video there. So first thing first, we have radians there. Rather change these radians into degrees. Now when you change radians pi over 2 into degrees, you multiply by 180 divided by pi. So this means that we're going to have pi divided by pi, and 180 divided by 2. This is actually 90 degrees. It's easier this way than when you use radians, right? So we can rewrite this as sigma. Instead of writing pi over 2, we can write 90 degrees, the upper limit, and the lower limit is 0. So it's fine like that. But look at what we have there. We have sine 2x. So sine 2x is a double angle identity. You can write it as 2 sine x multiplied by cos x. There we go, multiply. And then we also have cosec x. Cosec is an inverse of sine. You can write it as 1 over sine x. There we go. And then let's not forget to write dx there. Since everything is multiplying there, we can say sine divided by sine. They will give you 1 multiplied by 2 cos x. So let's rewrite this further. So we can say upper limit 90 degrees, lower limit 0 open bracket. We left with 2 cos x closed bracket dx. There we go. And then from here we can start integrating this. So let's start. Y is equaling to, let's open our bracket there. Let's not forget these are indefinite integrals. So we have the coefficient, which is 2 there. So what is the integration of cos? We know that it's going to be sine x close bracket. Then we write the upper limit and the lower limit. So when you continue here, we're going to have 2 brackets. The first bracket is for the upper limit, which is 2 sine x, and then the upper limit is 90 minus the same integral there, which is the second bracket for the lower limit, sine x, and then lower limit. So we continue on top there, guys. Wherever there is x, we substitute with our limits. So on the first bracket, we're going to have 2 sine. Instead of writing x, we're going to write 90 there. Let's not forget these limits here, guys, right? This 90 there. So minus. So on the second bracket, we're going to write 2 sine. Instead of x, we're going to put 0. Again, let's not forget this here is a lower limit, the 0. So when you put this on a calculator, this here is going to give us 2 as an answer. So this here is our limit. You can write unit square as well, because this is the formula that we use to calculate the area. So this is our final answer. Our limit here is actually 2. Guys, I hope you managed to understand how to do this question paper. This was the last question on this question paper. If you didn't understand, go to the point where you did not understand, rewatch at that point. And if that doesn't help, you can leave a comment in the comment section and I'll try to help you to my level best. If this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with this question paper. I hope you managed to pass this question paper. And if you are revising, you can always go to the playlist. At the end of this video, I'll leave other question papers. You can click there to practice more. Thank you very much, guys, for watching. Till next time. Cheers.